This is just like a nasty question, and luckily they do not test this kind of thing very often. We can see that it involves trigonometry in some way, but I would say that this is not really the basic trigonometry that we often see on the test, where all we really need to know is SOHCAHTOA. The couple clues about that is, I mean, for one, the answer choices look really, really messy, so we should be like, this seems kind of scary. Plus, we're not dealing with degrees, we're dealing with radians, and that usually means kind of danger with trigonometry. And specifically here, they're really asking about the unit circle, which is a very complicated thing that has lots of stuff to memorize. And on the SAT, you're maybe going to see one of these questions very rarely, maybe once every 5 tests at most. And it's a lot of memorization for not a lot of points. So I'm going to teach this question to you with the minimal kind of memorization that you might need. First, we need to just think about a circle in the XY plane. And the unit circle is really all about just what are the kind of landmark angles. So 3 pi over 4 is an angle that ends somewhere in this quadrant, okay? So it's going to start at the x-axis. That's how we think about angles when we're on the unit circle. And it's going to somehow end in that second quadrant, okay? Now, the first thing to remember when we deal with angles kind of that are all around, and I guess I should actually say, why do we know that it's over there? Well, if we break up the unit circle into 4 parts, we can see the little landmarks, right? So 0 is kind of over here. That's also 2 pi, because that's a full way around the unit circle is 2 pi radians. It's the same as 360 degrees, just a different way of measuring. So 2 pi radians is there. So that means halfway around would be over here, that's pi. Half of that would be up here, that's pi over 2. And if we think about it in terms of fractions, that really is kind of the same as half of pi. And if 1 pi is over here, half of pi is at the top, then 3/4 of pi is somewhere over here. Okay, so let's not get into the specifics of what the angle means quite yet, but let's just admit that it's in that second quadrant, okay? Now, of all the quadrants, there are going to be little patterns that repeat themselves about sine, cosine, and tangent and what is positive and negative. So the first step should be, let's eliminate half these choices because we should know whether this angle is going to be positive or negative when we take the cosine of it, okay? The mnemonic device that I learned in school is all students take calculus, okay? It's just a little mnemonic device, and the first letter of each of these words tells me what's positive in each of the quadrants. So in the first quadrant, all of them are positive. Tangent, cosine, sine, they're all positive in the first quadrant. Now in the second quadrant, what the S is telling me is that sine is positive, but cosine and tangent are both negative. So if we are in this second quadrant with an angle, we know that the cosine of that angle is going to be negative. Doesn't matter what the angle is. If it's in the second quadrant, it's going to be negative because of this rule. So that gets rid of C and D. And now, hey, 50-50 shot, not bad. Just to finish this up, in the third quadrant down here, tangent is positive, cosine and sine are negative, and in the fourth quadrant, cosine is positive, and sine and tangent are negative. So it's a little annoying, but all students take calculus. In a lot of these questions, if they do come up for the unit circle, it's enough to get you half the answer choices to go away because you know positives and negatives. Now, some people have this really well memorized, and they just know, oh, cosine of 3 pi and 4, that's going to be choice B. That's the answer. I don't have that memorized. I always have to like figure this out in the moment, mostly because it's not really a useful thing and there's no point in holding this in my brain. So I figure it out in the moment based on kind of what the problem requires. So what you should know here, and what really helps us, is that if we have 3 pi on 4, it's going to be exactly halfway between the pi on 2, the 90 degrees, and the 1 pi of 180 degrees. So basically what we're doing is we're forming a right triangle that is in this quadrant. And this is kind of where sine, cosine, and tangent come back into this. Even though we've got like a circle, we're kind of dealing with triangles, lots of triangles. And the way that I think about this is really by focusing on the top number, root 3 and root 2. And I know that certain triangles have root 2 and root 3 as kind of part of their structure, all right? And Basically, when you're thinking of the unit circle, you're always either thinking about one of these two special triangles. They're the two that are given to us in the formula chart at the beginning of every single math section. So this is kind of like why there's so much memorization with the unit circle, is you're remembering these two triangles basically, 30 degrees, 60 degrees, 45 degrees. You're memorizing the values of sine, cosine, and tangent for those things, but then you're doing it all the way around the circle. So you're not just getting up to 90 degrees, you're going, okay, then what's 120? What's 150, right? So in this case, what we're really dealing with is a version of a 45-degree angle. We're halfway between the 90 on the top and the 180 on the left, and so that's halfway between kind of any of these 90s is going to be 45. So what's really happening here, this is so confusing, is that this is a 45-degree angle, and so we kind of know that we're using this shape in some way, and look at what number is involved in this shape, radical 2. The radical 3 is involved in the 30, 60, 90. I don't really want to explain it any more deeply than that. I don't think it's worth your time, basically is what it comes down to. So if these come up, there's really just two things to remember. Number one, all students take calculus. That's going to very quickly sort positives and negatives for you, and so hopefully you can kind of get rid of some choices just through positives and negatives. It goes around the circle the same way the quadrants go around the circle, right, around the graph. The other piece is that the reason we care about most angles that we might get asked about, it's because they're special angles. They're 30s, 60s, 90s, or 45s, okay? And so in real practical geometry, we also care about those because they just tend to come up a lot and they have special properties. And so even though the unit circle is not included in this reference chart, we can kind of cheat it a little bit and just know that 30, 60, 90, 45, any of these are kind of somehow involved, and you can kind of try to match things up. And that's what I did here. It gets me the right answer, and I guess that gets me from a 790 to an 800 score, because that's about the only time you're really going to need to know this, is if you're getting a 790 and you want an 800.